Hi everyone, welcome to my channel. I am Dr. Shabazz here. So in this video we are going to perform binary logistic regression analysis with SPSS. So we have a data of 120 customers from service department and we are going to conduct binary logistic with one continuous variable, one dichotomous variable and one as dependent categorical variable. So before conducting the analysis we need to learn the logistic regression, threshold values, and the 6 conditions of binary logistic regression in SPSS. So we put the data as customer 0 equal to customer state and 1 equal to customer left because we are predicting customer status with odds ratio, diagnostics, and classification. Logistic regression models the logic odds of an event. Probabilities remain between 0 and 1 while predictors act linearly on the logic. The most important thing is that the structure of the data should be better than the normative data in logistic regression. So we coded data as tenure in months, 1 to 60 months, support calls in 0 to 10 calls, auto pay enrollment 0 equal to no and 1 equal to yes, customer status 0 equal to customer state and 1 equal to customer left. So there are also check 6 conditions before trusting the logistic regression model. First of all, the binary outcome mean dependent variable should have 2 categories. Exact should have 2 categories. Independent cases, appropriate coding, linearity of the logic, low multicollinearity, enough information. And we also know the threshold values to accept and reject the hypothesis. So the value to accept the alternative hypothesis we should have to say that the value of P should be less than 0.05. Hosmer and Lemeshow tells the calibration of the data. So the value of P should be greater than 0.05. So it means if the value of P will be higher than 0.05, so it means there is no calibration in our data. And the VF various inflation factor should be less than 5 and tolerance level should be greater than 0.02. And standard residual should be between plus and minus 3. Cook distances less than 1. So these are the threshold in binary logistic regression analysis. So now we go to our data set and we perform the binary logistic regression. We go to analyze, then click on binary logistic regression. We put the dependent variable in dependent list, customer status, and we put the independent variable in covariates. One independent as continuous variable and second dependent is the dichotomous variable. And go to categorical. So what is our categorical and dichotomous variable? Auto pay enrollment. And click on continue. Then we go to save. We need probabilities, group membership, standardized results, and cook distance. So click on continue. Options. We need classification plots, Hosmer and Lemeshow goodness of it, and then click on continue and click on OK. So we have the data here. Total number of sample 120 and dependent variable in coding as we coded the outcome variable customer state equal to 0 and customer left equal to 1. Categorical variables coding as this was dichotomous variable in auto pay enrollment. So we coded no equal to 1 and yes equal to 0. So there we can simply there were total 46 responses were about no auto pay enrollment and 74 they said yes to auto pay enrollment. Okay, so beginning block classification table, customer status state and left, and variables in the equation we can see here constant and unstandardized beta negative 0.731, standard error, Wald, t-value, and which is significant because the p-value is less than 0.05, not in the equation. This we need to see The sport calls score 7.844 and autopay enrollment 10.413. So in both cases, the p-value is less than 0.05. Okay, so go to next model summary. This is very important. In case of both R-square, Cox and Snell and Nagelkerke, so we can simply interpret that both dichotomous and continuous independent variable explained 14.9% of variance in customer status. And in case of another R square, 0.208 mean 20% of variance explained in customer status. As well, Hosmer and Lemeshow test suggested that the chi-square is 7.774 and the value is greater than 0.05. So it means there is no calibration in our data. And we go to next classification table and we see variables in the equation. So these are the main results, path model, and we can see here sport calls and the beta value on standardized beta value is 0.315 and the Wald t value is 8.293 and the p value is significant because the p value is less than 0.05. So in this case, we accept the alternative hypothesis that sport car significantly increases the customer retention, customer stay. On the other hand, auto pay enrollment unstandardized value is 1.427 and standard error and the Wald t value and p value is also significant, which is lower than 0.05. So in this case, we also say that auto pay enrollment increases the level of customer retention, customer stay. So in this way, we do the binary logistic regression analysis in SPSS. So we also see the probability plot. So predicted probability is of membership for left. So this was probability plot to show the probability of data set. So in this case, we find the binary logistic with one continuous and one dichotomous variable. We can apply other and we can take other multiple independent and dichotomous, including dichotomous and continuous variables. You can also see my other videos with two dichotomous variables and two continuous variable as independent variables. So if you find my video helpful, please subscribe to my channel and press the bell icon so you can get my next video initially.